Well, hello guys, here Mr. Yi with another video after a little bit, a few days without posting and making any video. Now I'm back. I was not well and I was a little bit busy as well. So we're going to be posting and we're going to start the videos on electrochemistry for the grade 12. It's a very important topic and it's one of the last topic. It carries a lot of marks, so I hope it helps. I'll make it as simple as possible and I will divide it in lessons, let's say short ones. I don't want to make them too long. Now the first one, we're going to be focusing on oxidation and reduction. What is the definition, what is that, as well as oxidizing agent and reducing agent. So let's start by saying what is electrochemistry. This is the part of physics or chemistry in this case that deals with the conversion between electrical energy and chemical energy. What is going to happen here? What are we going to see? We're going to see how chemical energy can be converted into electrical energy and how electrical energy can be converted into chemical energy. That is mainly what we are going to be seeing here. Now for this one, the first thing we're going to do is recall what is oxidation and reduction. It was done in grade 11, and if you didn't do it yet, so this is what it is, and it's quite simple. Oxidation is the loss of electrons by a molecule, atoms, or ion. So for example, let's say you have sodium and sodium loses electrons. If sodium loses an electron, one electron, it becomes Na plus. The electron must be there. You can have the electron, cannot disappear the electron. So this, we say that sodium is being oxidized. This is oxidation. So in this case, we say that sodium is being oxidized. Okay? And then we have, for instance, reduction. Now, reduction is when there is a gain of electron by molecule, atoms, or ions. For example, let's say Cl. Cl is a 2, it's a molecule in this case. Let's write it better. Cl2 is a molecule, and we are going to say that Cl is going to accept 2 electrons. Then if the Cl accept 2 electrons, it becomes Cl minus, but we have in this case 2 to balance the equation. We're going to speak about these equations later on, but we can see that Cl accept electrons here, and this one is reduction. So we can say that Cl or chlorine is being reduced. So sodium is being oxidized while chlorine is being reduced. That is quite simple. However, now we have to go to oxidation numbers. Without oxidation number, we are not going to be able to determine if a specific atom, ion, or molecule gain or loses electrons. So we're going to look at oxidation numbers, also done in grade 11. But once more, if you didn't do it, we're going to do it now. So it's not a problem. Now, rules. We have to follow certain rules to determine what is the oxidation number of a substance. Oxidation number is the charge an atom would have if it was in a compound composed of ions. So the charge an atom have, ion have the charge. Okay, and we're going to follow certain rules to determine what is the charge. The first rule say a molecule consisting of only one element always have an oxidation number of 0. When we say elements, one element, we mean, for instance, sodium. A reaction where you have sodium, that the oxidation number of sodium will be 0. Or for instance, iron, the oxidation number will be also 0. If you go back here, you can see sodium here is being oxidized. So if we look at the oxidation number of this sodium here is 0 because it is a molecule consisting of one element. It's not a molecule, but well, it's one element only. Okay, so those are the examples here. So you have any chemical reaction, guys, and you have a molecule consisting of one element, the oxidation number will be always 0. So that is quite important. Now, second rule, monatomic ions. With monatomic ions have an oxidation number that is equal to the charge of the ions. Now, the monatomic ion we're speaking about, for instance, H plus. Let me change this red color. I want red color for something else. For instance, let's say H plus, that is a monoatomic ion, means ions of one atom, that the charge of the oxidation number is positive 1. If we go to monatomic ions of Cl minus, we have the oxidation number is minus 1. If we have a monatomic ion of, for example, O2 minus, which is oxide, the oxidation number is minus 2. And I think you got the idea here, guys. Any monatomic ion will have the oxidation number which is equal to the charge of that specific ion. It's quite simple. This is a table on ions. I will post it also for you. And we're going to the third rule. In a molecule or compound, the sum of the oxidation numbers of for each element is the molecule or compound is going to be zero. This is mathematics and it's quite simple. Now, when we say molecule or compound, let's say for instance water, and it's a simple example, H2O, and let's use another compound like sodium chloride, NaCl. So what it means is that the oxidation number of the whole molecule is going to be equal to 0. And the oxidation number of the whole compound is going to be equal to 0. So that 0 is coming. Let's move this one a little bit to the right because I want to write more here. This is coming from the oxidation number of hydrogen, or what they say is that the oxidation number of 2 hydrogens plus the oxidation number of 1 oxygen will be equal to 0. This is what this rule is about, and it's important because sometimes you will have to learn some oxidation numbers, but other ones you will have to determine because it's not the same. So in this case, for instance, you have that the oxidation number of sodium plus the oxidation number of chlorine is going to be equal to 0. This is, in other words, what this rule is about. You need to learn that one. The total, the sum of the oxidation number of each atom in a compound will give you 0. That is quite simple. Now, rule number 4. In a polyatomic ion, the sum of the oxidation number is equal to the charge. Now, polyatomic ion, what are we talking about here? We're talking about sulfate, SO4 2 minus. We're talking about hydroxide, OH minus. We're talking about nitrate, NO3 minus, for instance. And those are some examples. There are more. I cannot write all of them. But in this case, what we need to know is that the oxidation number of the whole polyatomic ion, similar to the molecule, is going to be equal to the charge. So in other words, let's move this one a little bit to the right. There we go. I'm going to write with the first example. When you come here, this means that the oxidation number of these all sorry about that, let's do this, of this all ion is going to be minus 2. So when you add the oxidation number of sulfur plus the oxidation number of 4 oxygen, because you have 4 oxygens there, is going to be equal to minus 2. This is what it says, that rule there. And in the second case, in this case of the hydroxide, we have that the oxidation number of oxygen plus the oxidation number of hydrogen is equal to minus 1. And I'm not going to do the nitrate because I think you can see it by translation. There is the same 1. So when you add the oxidation number of each atom that belongs to that specific ion, the oxidation number of everything of the whole ion is equal to the charge of the ion. Why do we need this one? Because sometimes we have to calculate the oxidation number of some atoms. For instance, in this case, you will see just now that oxygen, you actually know the oxidation number, but you don't know the oxidation number of sulfur because it does change. Sometimes it's one number, sometimes it's another number. So this is quite simple. This is rule number 4. I hope I'm not going too fast. Please let me know if you understand in the comments. And oxygen atoms actually has an oxidation number of -2. Yes, very simple, very easy, very useful. Oxygen will always have an oxidation number of -2, except, so oxygen atom. Let's write oxygen atom. Yes, it is there. Oxygen atom, it is there. So we're talking about oxygen atom have an oxidation number of -2. Now, when I said oxygen atom is oxygen when it is in a molecule. For example, if we have the H2O that we spoke about, H2O, we can say that the oxidation number of oxygen within this molecule is going to be -2. We can write it here so we know that. So if we actually do this one, we already can use some rules here before we carry on to the next one. If we go on to this one, we can combine the rule there. We can say that the oxidation number of 2 hydrogens plus the oxidation number of one oxygen is equal to 0, because this is a molecule. We're going back to rule number 3. This one is equal to 0. Are you with me? So if we move in here now, we have the 2 times the oxidation number of hydrogen plus oxidation number of oxygen atom is minus 2 is equal to 0. And guys, this is just mathematics. You get that the hydrogen is going to be equal to minus 2 divided by, no, minus 2 is going positive to the other side. It's a positive 2 divided by 2, and that gives me a positive 1. So the oxidation number of hydrogen is going to be positive 1. This is one example of how to apply the oxidation number, guys. The oxidation number of oxygen atom is minus 2. When I said oxygen atom, when we mention oxygen atom, is oxygen within a compound. For example, let's say you have FeO, iron oxide. The oxidation number of this oxygen here in this compound is going to be minus 2. It's always going to be minus 2, except for hydrogen peroxide. In hydrogen peroxide, then it's going to be minus 1. Please, you have to be careful with that exception. Why? Because sometime in the exam, they ask you about deception to see if you understand the work. Otherwise, it's always going to be negative 2. And that comes to rule number 6. The oxidation number of hydrogen is always positive 1. Guys, we just calculated here. We just calculated, then we got the 1. So the oxidation number of hydrogen is often 1. Now, hydrogen as an atom as well. Hydrogen atom. So that means hydrogen atom means when it is within a molecule. For example, in H2O, we already know by rules that the oxidation number of hydrogen is going to be positive 1, and what is that? Positive 1, sorry. And the oxidation number of oxygen by a rule is already negative 2. So we don't have to calculate it. It's given to us. So anytime you see hydrogen or oxygen in any compound, you already do have compound or ion, it doesn't really matter. You already have the oxidation number of those 2 atoms there. So in any example, in any compound where you have hydrogen, for instance, let's say H2SO4. This one is sulfuric acid. It is a compound. Now, each of these atoms will have its own oxidation number. And this is what we are busy with. For instance, hydrogen have an oxidation number of positive 1. It is in one of the rules. Oxygen have the oxidation number of negative 2. It is in one of the rules. Sulfur, we don't know. So we eventually will have to get sulfur using the rules. Why is this important? It is very important, guys, because we need to determine what substance is being oxidized or reduced according to if the electrons were lost. Okay, we're going to look about that one just now in a minute, but this one is important. The oxidation number of hydrogen is often 1. Now, there is also an exception that you have to look, and it's when it's a metal hydride. For example, metal hydride, we're referring to well, instance NaH. Then it's another story. Then in this case, it's going to be negative 1. This one is the exception, and be careful, it's only in those examples there. Now, the oxidation number of halogens have always a negative 1. Halogens, we're referring to Cl, we're referring to F, we're referring to Br. Those are halogens, and all of them will have the oxidation number of negative 1. Now, we're making halogens when they are like atoms. Be careful with this one also. These are atoms. All these ones here are atoms. Be careful, these are atoms. If we have Cl2, that is not an atom, that is a molecule. And this, as a molecule, will have an oxidation number equal to 0. It was rule number 3 for us. You can go back and 4 in the video so you can see the rule. So be careful. These are atoms here. You can see, I'm looking for the highlighter. These are atoms there, and this one is a molecule. So be careful, don't you get confused. Halogens as atoms always will have oxidation number of negative 1. Now we mentioned as atoms is when it is, for instance, involved in a compound like sodium chloride, NaCl. So in this case, chlorine will have an oxidation number of -1. Rule 8 and 9, elements in group 1 will have an oxidation number of +1, and elements in group 2 will have an oxidation number of +2. For example, sodium will have an oxidation number of +1, and then magnesium will have an oxidation number of +2. So those are the rules. I hope it helped. I did not go through very fast. I explained each of them, and we have to apply those rules. We have to be able to calculate the oxidation number. So saying that, we're going to go back here to sulfuric acid and do the calculation. So let's take this sulfuric acid, for instance, and move it all the way to this side, and then this one, let's move it to this side, so we can use this sulfuric acid to calculate with one example. Let's say you're looking for the oxidation number of sulfur. Sulfur is straight in none of the rules. So none of the rules speak about sulfur itself. Okay, so we have to use what we know and the rules to determine the oxidation number of sulfur. Guys, it's quite simple. And we will this one to use by using mathematics. We have the oxidation number of 2 hydrogens, so we have to write a mathematical equation. 2 hydrogens plus 1 sulfur plus 4 oxygen is going to be giving me an oxidation number equal to 0, because it's a compound, and we say that the oxidation number of a compound is always going to be 0. Rule number 3. So when you add all of them, will give you 0. Now if you substitute, is 2, oxidation number of hydrogen is always going to be +1. So I'm not going to write +1, I'm just going to write 1. This is mathematics. Plus sulfur plus 4 times the oxidation number of oxygen is always -2, except for peroxide, which is not the case, and this is equal to 0. And this is simple mathematics. So when you finish the mathematics here, you'll have the 2 plus s minus 8 is equal to 0. And this one is even more math. When you go there, is equal to 8 minus 2. So sulfur have an oxidation number of a +6. Now, that is going to be the oxidation number of sulfur all the time? No, it is going to be the oxidation number of sulfur when it is in sulfuric acid. So if sulfur is in any other compound, guys, you do have to calculate it. That is why these rules are important. We have to make sure we know how to determine the oxidation number of certain elements. Now, what is going to be happening now? We're going to look at 2 new definitions of oxidation and reduction. Now this one is in terms of oxidation number. This one is in terms of oxidation number. So be careful, you cannot confuse the definitions, okay? Oxidation is oxidation, but it's in terms of different factors here. In this case, oxidation occurs when the oxidation number of an atom increases, and reduction occurs when the oxidation number of an atom decreases. Okay, so if we go back to the starting point when we spoke about oxidation and reduction in this case, and we are going to be looking at the oxidation number of each of this one there. The oxidation number of sodium is 0, and the oxidation number of sodium in an ion here is +1. You can see the oxidation number increases, therefore this one is oxidation. The oxidation number of that atom increases. If we go to this example, we have that chlorine, for example, here have an oxidation number that is going to be 0. In this case, chlorine is 0, is a diatomic molecule, is a molecule, the whole that molecule there is 0, and then if we move here, it have an oxidation number of -1. The oxidation number decreases from 0 to -1, and we say it is reduction. So we have 2 definitions for oxidation, and we have 2 definitions for reduction. We have a definition for oxidation in terms of electron transfer, which is the loss of electron, or we have a definition for oxidation in terms of oxidation number, which is where the oxidation number increases. And we have reduction in terms of electron transfer, which is when there is a gain of electron, and we have a reduction in terms of oxidation number, which is when the oxidation number decreases. And then we have a few more definition, guys, but I think the video is going quite long. So in the next video, very short video, and we're going to be talking about half reaction, reducing agent, oxidizing agent. We are almost done with this, but we are going to stop the video right now. We are almost near the 20 minutes. But thank you for watching. I hope it helped. If you struggle with this one, you will not be able to do the electrochemistry that is coming then. Next video, we're going to be talking about half reaction. It may be even a shorter video, reducing agent, oxidizing agent, and we're going to one example here when we have to do everything done in this video and the upcoming video. Thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.